Hi everyone. Today I'm going to talk about machine learning. Indeed, what is machine learning and how can it be used in today's life? And what are certain examples of machine learning? I will go through all of these things in this presentation. So what is machine learning? Machine learning is an application of artificial intelligence or AI that provides systems with the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. Why do we need machine learning? We know that there are a lot of machine learning algorithms that have been around for a long time, but the ability to automatically apply complex mathematical calculations to big data over and over, faster and faster, is something that has just been recently developed. So for example, a few widely publicized examples of machine learning applications that you may be familiar with are the Google self-driving car. This is the essence of machine learning. Then you have online recommendation offers, such as those from Amazon or Netflix. Like these are machine learning applications for everyday life. And then knowing what customers are saying about you on Twitter is machine learning combined with linguistic rule creation. For example, you have Twitter streaming data, which goes into an API and then into a Firebase database and BigQuery. And then you have Twitter data, and then you pre-process the Twitter data. You train the data using machine learning algorithms, classification using machine learning algorithms, and then you have the output with the predicted sentiment labels. So this is one example of machine learning. So due to these reasons, we need machine learning. And also another example of machine learning is fraud detection. So that's one of the most obvious important use cases of machine learning in our world today. Also, most industries working with large amounts of data have recognized the value of machine learning technology. By gleaning insights from this data, often in real time, organizations are able to work more efficiently or gain an advantage over competitors. Who uses machine learning? So financial services, for example, banks and other businesses in the financial industry use machine learning technology for two key purposes: to identify important insights in data and to prevent fraud. The insights can identify investment opportunities or help investors know when to trade. Data mining can also identify clients with high risk profiles or use cyber surveillance to pinpoint warning signs of fraud. Now, machine learning is used in healthcare. It's a fast-growing trend in the healthcare industry, thanks to the advent of variable devices and sensors that can use data to assess a patient's health in real time. The technology can also help medical experts analyze data to identify trends or red flags that may lead to improved diagnosis and treatment. The government uses machine learning since they have multiple sources of public data that can be mined for insights. Analyzing sensor data, for example, identifies ways to increase efficiency and save money. Machine learning can also help detect fraud and minimize identity theft. Then you have retail. Websites recommending items you may like based on previous purchases are using machine learning to analyze your buying history. Retailers rely on machine learning to capture data, analyze it, and use it to personalize a shopping experience, implement a marketing campaign, price optimization, merchandise supply planning, and for customer generating insights. So here are the various types of machine learning algorithms. You have supervised learning algorithms, unsupervised learning algorithms, semi-supervised learning algorithms, and reinforcement learning algorithms. So what are supervised learning algorithms? These are the types of algorithms in which you are trying to predict a response variable. Types of supervised learning algorithms are classification algorithms. These have a categorical response variable. For example, 0 or 1, survived or died, passed or failed, accepted or denied. And you have regression algorithms, which have a numerical response variable. For example, stock price, house price, test score. Then you have supervised learning algorithms. So supervised learning algorithms are the most commonly used machine learning algorithms. Types of supervised learning algorithms are multiple linear regression, logistic regression, boosted decision tree, feed-forward neural network, support vector machine, and k-nearest neighbors. What type of supervised learning algorithms are these? So this is a quiz just for you to understand, just to get an idea of whether you understood this, whatever I've said until now or not. So what type of supervised algorithms are these? Predicting if a person survives the sinking of the Titanic or not based on his age, gender, number of family members. So now this one is actually a classification model. Then the second one is predicting the price of a stock for tomorrow. Since the stock is numerical, so it is regression. Predicting the price of a house. Again, it's numerical, so it's regression. Predicting whether a loan applicant is given a loan or denied. This is a categorical response variable, so it's classification. Predicting the president's approval rating. This is a numerical value, so that's why it is regression. Predicting Virat Kohli's score in the next game he plays. This again is numerical, so it's regression. Predicting the number of cases of COVID-19 globally by January 2021. So that is again, so that is regression because it's a numerical variable. Predicting whether a person has or does not have COVID-19. Now this is a categorical response variable, so hence this is classification. What are unsupervised learning algorithms? These are the types of algorithms used when there is no dependent variable and you're trying to find common groups or patterns in the data so that you can cluster the data in an optimal manner. Which of these are examples of unsupervised learning? Predicting stock price? No, it's a numeric response, so that's why it's regression. Partitioning customers into groups based on their preference of shoe type? Yes, now this is just clustering, so that's why it's unsupervised learning. Finding out which groups of patients like Indian food or Chinese food, etc. Now this would be again clustering because you're not predicting anything, just trying to group data into similar categories. Deciding if an email is spam or not spam. This I believe is supervised learning because it is classification. Types of unsupervised learning algorithms are k-means clustering and hierarchical clustering. Now I would like to talk about a supervised learning algorithm called the k-nearest neighbors algorithm. The k-nearest neighbors algorithm, or KNN, is a simple machine learning algorithm which can be used for both classification and regression. So the plot in front of the screen is the fitted function for KNN regression on a two-dimensional data set with 64 observations. So we can say that k is equal to 1 results in a rough step function and k is equal to 9 produces a much smoother effect. This picture has been taken from an introduction to statistical learning. So how does the k-nearest algorithm work? How does the KNN work? So for example, if you have a certain value of k, in regression, the KNN simply takes the average of the values of k nearest points in the data to the point of interest whose value we are interested in predicting. And in classification, KNN selects the most common class and assigns it to the point of interest. For example, if you can look at the picture, if we are trying to predict the color of a new ball, and if k is equal to 3, if two balls near it are blue and one ball is yellow, then KNN will assign the color blue to the new ball, which is the majority vote. And if k is equal to 6, then you have 4 balls which are yellow and 2 balls which are blue. So the value of k is equal to 6. For that, the majority vote will be yellow. What do different values of k in KNN mean? A low value of k, example k is equal to 1 or k is equal to 2, implies a highly flexible model like bagging, boosted decision trees, or random forests. Highly flexible models are useful because they can solve complex problems and also fit well to non-linear data. However, they can suffer from overfitting. The model will also tend to have higher variance and low bias. Higher values of k, example k is equal to 10, k is equal to 12, implies an inflexible model like multiple linear regression. Inflexible models work well on data in which the response variable has a linear relationship with the predictors. The model will also tend to have high bias and low variance. So this brings us to the question, what is bias and variance in machine learning? Bias is the error measured when your model is too simple and when you're trying to model complex relationships in your data. For example, when you are using a linear regression model to fit a dataset which has a highly nonlinear relationship between the response variable and the predictors. In this case, simple models like linear regression suffer from high bias but tend to have low variance. What is variance? Variance is the difference in your model's predictions when you use your model to make predictions on two separate datasets. Flexible models like boosted decision tree and random forest tend to suffer from high variance due to increased likelihood of overfitting the data. These models tend to suffer from low bias but have high variance. So in the plot below, we can see how model complexity focuses on total error, which is a combination of bias and variance. The challenge in machine learning is to find the optimal model complexity in which you have both low bias and low variance. So the optimal model can vary differently for different data sets, and it's always a challenge to find the optimal model which has both low bias and low variance. But in data science, there is no one size that fits all. Different models work optimally on different data sets. So that's why bias and variance is very important, and the bias variance trade-off is a problem that people are trying to solve in machine learning. So that brings me to the end of my video. Thank you for giving me the opportunity to explain my understanding of machine learning. Thank you and have a great day.